quality, but more sound.
Yeah, as you can see, we are perfectly prepared for this with all technical issues. I'm here in another room, not working on my usual development device, and Malte has some microphone issues.
Well,
But
at
we'll
least
manage.
the technical issues will be all over now, and we can have a fantastic workshop.
Yes, and Dominic seems not to be here, so I would say we just start. And
sounds good.
Hopefully he will join later. Okay, yeah. So welcome again, everyone, to Gold Weekly Workshop Series session. This time the workshop is called Shopping List with a Sprinkle of Intelligence, and that's basically what we're building. So we want to create a shopping list, a shared. And I will just create the screen share. Give me a second. So please let me know if you cannot see the screen.
I can see it, so it should be good.
Okay, great. Yeah, then we can start. So my name is Sandro. I'm Gold Student Ambassador at the University of Stuttgart in Germany. And I'm also research assistant and PhD student there. And today I'm here with Malte, who can introduce himself.
Hi, I'm a student. I'm a bachelor student in computer science, also based in Germany in Karlsruhe. And I'm excited to work on bots again. I have worked on them a couple of years before, but not as intensely as right now. So I'm excited to share with you what we have for you.
Okay, then just start with a brief motivation. We have here three friends, John, Alice, and Bob, and they want to have a shopping list. So usually their approach is to write their items down, and when they go shopping, they chat with each other. It might happen that somehow they forget to buy something, for example, the milk. And obviously that's not optimal because now they cannot bake. If you speak up. Yeah, how does the architecture look like? So we have 3 or 4 main components. The first one is our bot itself. We use the Microsoft Bot framework in this workshop. And for our text inputs, we will send the text into LUIS. LUIS is a language understanding API, which uses natural language processing to identify the intent of the text and entities we are writing. So on the next slide, we can see this in more detail. And from the result of LUIS, we decide which Azure function we are calling, for example, adding an item, getting all items, mark or unmark an item, or remove items from our Cosmos DB database. Okay, let's take a look in LUIS language understanding. Just imagine we have a sentence like this one. So add 2 kilogram bananas to my shopping list. And for example, Malte wrote this in the chat. And then our chatbot is sending this sentence to LUIS. And Louis will identify the intent from this add and two entities, one for the unit and one for the item. In detail, we have two entities for the unit. So one is the value and one is the unit name, kilogram. But for brief understanding, we just used a simple model. And which intents do we have in our trained Louis? We have adding. As you can see, we have get all. We have remove by an ID. However, this is not really that we need to write the ID. We just can talk to the bot which item we want to delete, and the bot will identify the item. And then we have an update on multiple properties. Okay, is that clear from this point? Or do you have any questions? Okay, great. So if I would write now, I don't know, get all items from my shopping list. Then Louis would identify the intent get all. And obviously everything works just if you have enough training data for your sentences. So for this workshop, we will provide you with an Louis instance, which is already trained. However, if you want to do it on your own at home after the workshop, you need to set up a Louis instance and provide the training data yourself. However, you can export we can export our Louis instance as JSON, and you can import it. So you can already use our training data. And I think there was something in the chat, so it's okay. Great. If you have any problems understanding us, just let us know. Great. So the next part would be the bot itself, and the bot basically consists of dialogues and steps we will build. So a dialogue is basically a chat, a part of a chat for one specific intent. So let's consider we are writing this add, which is an identifier for our intent. I hope you can read what I'm writing. Then Louis will say, hey, just start the add intent, and our bot will navigate to the dialog for this adding intent. And a dialog consists of several steps. In our case, we have, for example, an initial step, a step for adding an item's name, and a step for adding units for the items. And adding units is optional in our bot. So you can just write add bananas and everything's fine. Okay, and depending which information you're providing to the bot in each message, it might happen that some steps are basically skipped. Because if you're writing add 5 kilogram bananas, then there is no need to ask the user which item he or she would like to add. And also the same for the unit. However, if you write add bananas, then it might happen that the bot will ask you whether you would like to add a unit. Good. So let's come back to our architecture. We have two parts in this workshop. The first part is here. Our bot and Louis. And the second part is then the Azure functions and storing our data persistently in a Cosmos DB. Great. So perhaps Malte can write the GitHub link.
Yes. So as you might see furthermore previously in this chat, if you want to follow along, it would be helpful if you have Node.js installed and the bot framework emulator and Visual Studio Code with the Azure Function extension. However, this is totally optional, and you can simply also come back later if you want to revisit building the spot. Then you'll find all the details, and we will, of course, afterwards provide you even more information at the end. For now, if you have all the prerequisites installed, you can use Git to clone our repository from GitHub, and then you can follow along while we will show you what to do. For us, it might be helpful if anyone needs some time to follow along, if they could raise up their voice or write in the chat, so we simply know how fast or slow we should go.
Yes, so you can see we had some troubleshooting before. If you cannot see the chat, then you might just type this one. I hope you can see that. Yeah. So now the iMac is struggling, and I hope you cannot hear the radiator. Great. Let's start.
Yes, let's start with the bot.
So if you cloned the repository and opened it in VS Code, you might have a structure like this. You have two main parts. One is the bot here in the upper part, below part, and the second one are the functions in the upper part. And you should have installed the Azure extension for functions just to start them at the end. And if you do not have a Azure subscription yet, then you might just Google for Azure for Students and subscribe there, so you can get $100 per year for free. However, we will not need any of the budget. It's just that the Azure function might need an account. Okay, yeah, Malte and I will work together using Microsoft Live Share, so don't be surprised if anything changes here and I don't do anything.
So our plan is that for the bot, I will start walking you through what we did, and Sandro will pin me so he can follow me along. And when I switch files to the index file, he should jump towards me. Sandro, I think you still have to pin me. So on the top right corner.
So if the text is too big for you, then just let us know and we can zoom out.
And now you can see my cursor and I can walk you through the code. Okay, so let's get started. Basically, a bot is just a web server. So you define endpoints, or it has specifically defined endpoints in this framework where you can implement your functionality depending on the message you receive. This is quite nice because then different channels, they are called. So for example, Telegram would be a channel, or Microsoft Teams or Skype. All these different platforms can call you your chatbot without you having to write code specifically for the platforms. In addition, building a bot kind of requires rethinking. So maybe if you're used to building web servers, you're also used to building web apps, and there it's really, or native applications where it's all about the UI. The bot, however, is more about the text and the information and the functionality it provides. On the one hand, this makes life easier, since you don't need to deal with all the nasty CSS. On the other hand, it makes some things more complex because human language by nature is quite complex, and having to deal with all those cases can be difficult, but there are tools to help. So I just wanted you to show, to see that this is basically the server where we wire up everything for the bot. And we can see there's an endpoint. When it receives a message, the bot will run. Well, how does the bot look like? Besides all the plumbing that we need to set up, it boils down to dialogues. A bot consists of dialogues where you can step through dialogues and ask the user a question like Sandro explained before. Right now, I want to start out by showing you our add item dialog. As we can see, we still have some code missing. Now, our objective is to find out which item the user wants to add when they write us a message. Here on top, we can see that we have an add item dialog class, which extends this cancel and help dialog class. This alludes to the part, the cancel and help dialog that I mentioned before, that human language is complex. And by abstracting some of the aspects here in this cancel help dialog, we have abstracted the fact that a user should be able at any point to ask for help and to cancel, so that we don't end up with a bot that is still at the step where it wants to know the item name, add to the shopping list, and the user says cancel the entire time, and it's just reporting with the same question. We won't bother with that for now. So we want to look at the add item dialog. In the constructor, we basically set up the flow of this dialog. The dialog consists of different components. So we might want to ask the user for text input. We have our own unit dialog that we will look into in a second that we can add. And then we have those predefined waterfall dialog, which is provided by the framework, and it allows us to define steps that we want to go through in this dialog. And so you can think of them almost as messages. So the bot might send a message, the user might respond, and then the bot should continue with the next step. So the entire part of the sending the message and waiting for the user input will be taken care of by the framework. So we don't need to worry about the state too much right now. We can be assured that once we've asked the question for the item and we receive an answer, this step will be run. So let's get started with the steps. In the first step, we want to ask the user for the name of the item they want to add to the shopping list. As you can see, we've already set up the signature for this method, and we will start entering some code. This will be important more later, but basically the step context contains all the input for this dialog. So through that, the bot framework tells us which kind of message it has received and more information that we can use. So first, we will start off, and from
Malte,
yes,
you have written cost.
Yeah, sorry. That's the benefit of live coding, I suppose. First, we might already have some items as an input. So this will become more important once we've added the LUIS intents. But basically, the LUIS intents are collected before the dialog is run. So maybe the LUIS language understanding has already figured out the item, and it can already provide us the item in the input, and then our dialog is the easiest because we don't need to do anything anymore. So we can simply check in this step. We want to know the name for the item. So if it already exists, that's much. If we've already received an item as input with name, this step is be done. We don't need to query for the item's name anymore because we already have it through LUIS, which we will see later. And then what we do is we tell the framework that our code is done, and we sort of give the responsibility back to the framework, and it will figure out which step it needs to run next, if it needs to wait for user input, and so on. We do this by using the input we've received from the framework and calling the next function on it. Through the next function, we can provide input for the next step. Because in the next step, we want to be sure that we have the item name. The input for the next step should be the item's name. If we aren't lucky and have the item name already in our input, we need to ask for it. So let's create a text. And in this text, we simply ask which item do you want to add? And then we take this text, which is right now still a string, and we create a message. We can use this factory that is provided by the framework and call the text function. And then let's see what it wants. So it wants the text for the message. We've just defined that, lucky us, the message text. And then we can also, which is specific to some channels where maybe you know bots in the form of bots speaking to you instead of you having to write text. So for example, Alexa, Google Assistant, and Cortana. Sorry for triggering them if you have some around. However, we can also, this functionality is also provided by the bot framework, given that we provided some text that it can speak out. And then we see that we can pass it an input hint. So let's have a look what the input hint type has available. So that's an enum. Input hints. We have three options: accepting input, expecting input, ignoring input. With this, once the bot framework sends the message to the user, it knows if it should reject input from the user. So the user shouldn't be allowed to answer to that question directly. Or maybe we need the user to respond to us, which will be the case right here because we've just asked him a question. So we need to receive an answer for that. Or we could say, well, we can handle input, we don't need it, it's up to the user, and then we would select accepting input. Here we want to expect input though, because we've just asked the question. Now that we have the entire message, we are done for this step, and we can take the context and send a prompt by calling the prompt function. And now the text prompt component we've added previously becomes important. So as you can see here, we've added this to our dialogues that are available within this dialog, and we've given it an ID, which we've noted down here. So in the prompt function, we can pass any ID of a dialog that is available within this dialog. That's one text too many. And then the bot framework will go ahead and call this dialog. And for us, it's nice because the text prompt is already provided with the framework. So we already get that functionality for asking a prompt, which will be, in our case, the message which we just created with our question. So that's all for this step. Maybe you see what I meant with that. It's a different thinking when you think in messages compared to in UI and elements and buttons arranged on the screen. We don't need this return anymore because we have the if-else all covered, and we are done with this step. So let's recapitulate. In the first step of this dialog, we ask the user which item they want to add if no item name was provided as the input. Now, in the next step, which we've defined here, added to this dialog here, which is the query unit step, which we find below here, we are ensured that the input for this step will be the item name, either by us directly passing it here because we know it, or by asking the user the question and the user answering a message, which will be also a string. So we can go ahead and start with the second step, where we first of all receive the item name from context, and the input will be passed for us as the result. So the result in this case is the result of the text prompt dialog we invoked, and the bot framework will pass it to us. Now that we have that, we will also take the previous item, the previous input. So this we can pass along with the option arguments through the entire waterfall of the steps. And that's the wrong class. So here. And why do we do this? Maybe we already received the complete item as the input. So we pass it along, and in each step, we can either add information to that item that is still missing, or maybe we don't need to add any because it's already existing. So in each step, we take the already constructed item, and here in this step, we add in each step, we add the input from the previous step. So here, the previous step, we received the, I don't know what's wrong with my typing. We received the item name. So now we've taken care of that and constructed one part more. However, we also want to go further and ask the next question. So in this step, we want to ask the user for the unit. So maybe you want to add a unit like kilograms or ounces to for the item that you've just created or named. So if the unit of the item we've already have is not defined, we need to query for it. And for right now, we have it really easy because we begin a different dialog. Remember in the beginning, I showed you that we've added this unit dialog. By encapsulating the different functionality in different dialogues, we can easily reuse them and don't need to ask the whole dialog for the unit, need to build the whole dialog for the unit. Instead, we will go ahead and we tell the bot framework with begin dialog that now we want to start a different dialog. And in this case, we want to start the unit dialog, so we pass it the ID of the unit dialog. So basically, these dialogues, that's not so important right now, but it becomes important later when you get into more details of the bot framework. But dialogues are arranged in a stack. So the first dialog is put on the stack, and then its flow is the bot framework works through its flow. And then if you add another dialog in the middle of the other dialog, this will become on top, and then it will continue the first dialog only after the dialog we put on top or we started is complete. So we simply start the begin dialog, and we will let it do its thing, and we let it take care of querying for the unit. However, in the other case, we might already have an unit passed, so this input might already be complete. In this case, we can, again, like we did previously, simply tell the bot framework to run the next step, and let's pass it also some input, so we already know that we have the unit, so we can pass it the unit as input. Now, for you to understand those dialogues quickly or better, I want to have a quick look at the unit dialog that we've started here. So if I go to the top to this class and I go to the definition of it, you can see we've also written this class. It also extends the cancel and help dialog as the other one because we want to allow the user to interrupt and say cancel and have the dialog stop, which is taken care of by the class we extend. We have quite a similar setup, except that we have different steps. So here, in the first step, we ask if the user even wants to add a unit. And then we will add, this is a yes and no question. So the user, we can use the confirmation prompt for that is already provided by the framework. The next step, if the user wants a unit, we go to the next step. And if the user doesn't want a unit, we are done here. We can finish the dialog. If the user wants a unit, we'll simply go through and first ask which unit, so kilograms, grams, whatever is common in your country. And then once we know that information, we can ask the user to provide how many kilograms. And then in the last step, we build together the unit and we are done. So just for you to know, this is also implemented. This code is already available, so we didn't take out any code here. But basically, you want to encapsulate the different functionality into different dialogues, because then, as you can see, we have it really easy here to query for the unit. Sandro, are you still following me?
Yes, I'm still following you.
Oh, because I also see your cursor. I thought it should be exactly at my position. Okay, so now we are back in the add items dialog, add item dialog, and we finish up our last step. We've asked for the which item the user wants to add. So do you want to add bananas, apples? Then we've taken care of the unit dialogues getting started, and the unit dialog asks the user, do you want to add a unit and which one, and then how much of it. And with that, in the last step, remember this is called after this unit step. So we are sure that we have a unit passed as its input. We take that unit and we have it here in the results. And as a unit. And then we also, like before, like we did on top of here, we take the item that we've previously constructed through the previous steps. And to that item, we can now add unit. Okay. Maybe it's worth the look taking a look at the item. So that's the class we've defined for it. The intent and ID are basically information that we will generate later. But for the user input, we simply need the name and the unit for now to create a new item. Based on this information, we can now go ahead and finish up this dialog. So what we will do is we will create our own result, and we use that to provide the dialog ID of the dialog. This is, so its ID and the item that we've just created. So we can take the item here. And now, well, what do? We also we return the flow back to the framework. So this dialog is all done, and we tell the framework that this dialog is done by calling the end dialog functionality. And here we constructed the result, so we can pass it to the framework, and the framework will make sure that whichever dialog calls this dialog, this add item dialog, gets this result we just queried. Well, now you might ask, we have this dialog. There's already a little bit of help from the bot framework, but surely the bot framework doesn't know automatically when it should call this dialog and what it should call afterwards. Well, you're right. So we need to do a little bit more to get the add item functionality working, but it won't be too much anymore. For that, I'll open the main dialog file. And here, this dialog has been set up in a way that the bot always starts out with this dialog. No matter which input it receives, this dialog is started. So as the previous add item dialog, we add some of our own dialogues and some predefined dialogues from the framework to this shell of dialog. So if we look closely, we can see that in the constructor, we are passed an add item dialog. I hope at least that you remember that we just wrote this, and we can take it and add it right here. We won't worry about all the other ones, but you can see by the namings that all these dialogues take care of the different functionalities. For now, we just focus on the adding an item functionality. I've told you that this dialog is set up to run when the bot receives a message, so which is why it has also this run function, where it depending on if there's still a dialog running or not, if there's no dialog running, it will start over with this dialog. And this dialog has some steps itself. And now we get a little bit into the Luis part. So you could take this concept of dialogues and build a bot with it and be fine. However, your bot will most likely rely on having very precise input from the user. You might implement your own functionality to be a little bit more flexible. However, I think you all probably can see that otherwise you would need the user to require to write exactly like add to call the add functionality. And if the user might write I need, then your bot will probably not understand it unless you've taken care of it by hand. In addition, you would need to parse the input yourself. So you would need to find out which part of the sentence the user gave you is the command or the intent, and which part is the data, for example, in our case, the list items in the shopping list that you need to handle. Well, we don't want to do this because then it will quickly become really complicated, or our bot will be simply quite dumb. And nobody wants a dumb bot. So we will use Luis for this. So in this regard, I hope you know that Luis, you know now that Luis is optional. In this step, however, we will take care that we have Luis configured. The bot will run without it, but we want to have it configured. Otherwise, it might be more on the dumb side, this bot. By having Luis configured, we can here, when we receive the first step and we receive input, we can take this recognizer, this Luis recognizer, and we take the input and execute a Luis query. So we basically receive the message, and we first step push it off to Luis to let it do its thing, and hopefully we'll receive a more intelligent result. So we'll have a Luis result now. And we can then look up what Luis thinks this command means. So maybe, or hopefully, Luis could find out that it will be the add item intent. And in this case, we should run our add item functionality. Well, right now it's not doing much. However, we'll change that. First, we might already have, or we might already have input in the result we got from Luis. So let's ask the Luis recognizer what it thinks the name we want to add is. So we pass the result, and we might receive a name or we might not, depending on if the user might have just entered I need or add. So maybe we don't have an item, or maybe the user only, or maybe Luis couldn't quite understand it because it was too complicated. But maybe Luis is completely fine, and in the examples you could see in the slides, it could extract the name, and maybe it could also extract the unit. So we can get the Luis unit. So we ask Luis what the unit entities are, and take that as well. And on top here, we've already constructed an item for us, which we want to work on. So we take both of the input that Luis could maybe give us, or maybe it couldn't. Either way, we will take it and we will go from there. We'll take all the data that we can get. And with that information, we simply go ahead and guess what? Maybe someone of you can write in the chat what we should do next. So we have some input. We want to add an item. If anyone has an idea what we should do, please feel free to let us know. So basically, I might hint a little bit, but we've just spent the previous time writing a dialog. So what we will do, we'll use the add item dialog that we've written before, pass it the input that we might have gotten from Luis, and hope that it can either enrich the input by querying the missing name or the missing unit, or if the input is totally fine, it will just pass through and we will get it back anyway. So we use the begin dialog again, and we do the add item dialog. So this is the ID of it. And as an input, we pass it the item that we've received from Luis that might be complete or might not be. Can remove this break. And now we've kicked off the adding the item dialog. Well, in the adding item dialog, we didn't do any logic for actually saving the item. We just returned it. So if we also return it here, then we need to look somewhere else. Actually, we need to look in the next step because this will be executed next. And for that, we will scroll down past all the other functionality that we've already implemented for you and go to the final step. This step is the final step of this main dialog. It will be called, in our case, we can peek here. We've defined it after the act step. So we've already did the act step a second ago. And as such, we know that the final step is called the last. So in this step, we received the result from the dialog that was called that finished, or the step or the dialog that finished previously. So maybe it might be a dialog or a step where we don't have any input. But if we have some result from the previous dialog, we check here, we get that result, and we can find out over the dialog ID which dialog it was. And we can then implement storing the item. So after the add item dialog, we know, because we've written that line of code where we returned the item that we queried. So we should use that item now and make sure that we can save it. So let me just, we know now that this was the add item dialog that was run previously. So we'll do a simple cast and cast it to the add item dialog result. So we get all the intelligence magic of auto completion. And now we can go ahead and look at into the result and take its item. So the dialog has taken care of getting all the information for us. And now we can basically, we also want the user to know whether or not we were successful in adding the item, because transparency with a bot is really important. If a bot doesn't tell you what it does, you're probably really confused and you don't know what to do. So if we are a bit more transparent, it will definitely help. So if we assume that something went wrong, we will simply let the user know and they might need to try again later. And now we take care of actually doing the action. So hopefully it won't go wrong, but we got a message for that just in case. Adding the item in our case will be calling a function of a class that we've built. So this is the shopping list. Okay, when auto completion fails you, here we are. Shopping list function service. So it's basically a class. We can simply look into it because there is no magic to it, but we've put it here in this folder where we basically extracted all the calls that we will make to persist the item and that we will look into further down. But in our case, we will call this function where we do a simple HTTP request. So just so that we don't need to worry with all the URLs right in here, we can simply call our service add item, and it wants the conversation ID. So the conversation ID we use in this case to associate the shopping list with the specific chat, so that when you come back to your chat, you get the same shopping list and you don't get my shopping list. and I don't get you a shopping list. And we also input the item, we've called it item to add. And this will do the request, and we will see that later. However, now we have a result from that call, and if the added result, so that's an HTTP result, is okay, we are happy because we know that everything went fine, and we can change our error message from on top to something better, and we will let the user know that the item they've provided, the wrong parentheses, so we want to use some variables in the string, we need to use those backticks, and then we can get the item converted. So that's the simple string conversion that I don't want to do right now here. So we have a function for that, where we pass it the item to add. So this will make the text a little bit nicer, because now it will say I added, and then the item can represent itself, so it can show, okay, I've added 1 kilogram apples, whatever, to your shopping list. So again, we let the user know what has happened, but so far we've only have the text of the message. So now, again, like in the previous steps, we are now happy with what we did. We've got the item, we've sent it off to persist it, we have a result from that, and we can send, or let the framework send an activity to the user and pass the item added message that we've just created as the arguments, and right now we are done. So input hint should be one of those threes. So we will ignore any input. And by doing so, we basically have finished up this dialog. Maybe not. And step context. Okay, so maybe it's a nested member. Send and activity, maybe. Yes, here we go. Here we have the right method. So step context, the context, and the send activity. And we are done with this part. We also have already implemented all the calls and saving updates that the user might do, removing items. And at the end, we finish up the dialog and start all over again by removing this dialog and putting a new one on top. Whew. So now we've seen the basic code for building the add item functionality as the chat kind of progresses. And I think next up, I will show you a little bit about the LUIS. So for that, we will switch over into the browser and go to your Azure portal. And in our case, we already have a resource group, but I will go through with you and create this LUIS resource that we need.
So for all of you who haven't worked with Azure yet, resource groups are basically like Java packages. So you're grouping your cloud services together and you can manage them within the group, for example, deleting the complete resource group or shutting them down.
Yeah, you're right. So good call. But for now, we can just go to the left side menu, the hamburger menu, and there we will find the create resource. So we click it.
Yes, and you can also use the search if you...
Yeah, in Azure, there are many ways to achieve the thing, but I will just step you through here. So depending on your knowledge, this will show you all the services available, and we will just use the search box to search for Luis. And then we will select the language understanding one. Now we can hit create, and it will ask us for information it needs to create this resource. First, you need to select a subscription. So as Sandro mentioned in the beginning, get a free subscription if you don't have one, or use your existing subscription. And you can either hit create new on the resource group, or in our case, we already have one resource group where we have all the other resources for the bot and the database and the function that we will show you later. So we will select that. So we have everything grouped together.
So Malte, I'm not sure right now whether it's a workshop bot or shopping list bot workshop.
It's shopping list bot workshop.
Okay, thank you.
And then we need to enter some name. So that's completely up to you. We will probably name it shopping list Luis. And that will not do. Oh, okay, so this name needs to be unique. So I bet somebody else already has this name. I'm pretty sure that might be one of us, but maybe if we add, yeah, shopping a spot, that's fine. It just needs to be unique, and you might need to choose a name that you can recognize later, so you can manage your resources. Now we have two more points that we need to configure. So first here, the authoring and the prediction resources. So the authoring resource is the one that will be used by Luis to, when we create intents, to run the machine learning algorithms on them. So here in our case, because we are based in Germany, we will choose West Europe as the location. Just choose any location that is close to you or far away. With the internet, with the kind of thing we are doing here as a workshop, it doesn't matter. Of course, if you're in production, you probably want to be as close to your users as possible.
Because
and then in
the reasons.
Yeah. The internet seems fast, but it still is limited by physics, so things still need to travel around the globe, and there's still lots of layers in between. But let's get back to the resource group, and we will simply select the free option. So as Sandro mentioned, you need the subscription, but you don't need to pay if you don't want to, for some resources and for some limitations, of course. For the prediction resource, so this one will be used by Luis to actually receive the calls and to recognize the intents. So you could have your authoring close to you where you live, but maybe your users are on the other side of the globe. Then you probably want to have your authoring resource close to you, so you have a low latency when you create your Luis, and your users also have a low latency when they use it. So for us, it will be the same. So we can just pick West Europe, and we will also select, in our case, we will select the standard one. You can select a free one, but we've already used that, so we can't have multiple free ones, but you can if you want. And then to finish up, we have provided all the information. We can hit review and create. Great. And so now this will take a second. So during that, maybe if you have any questions, now would be a great time. Otherwise, I will take a sip of water because I feel my mouth getting dry. I'd probably encourage you to take also maybe a little bio break, or the deployment is already complete, but make sure that you have enough to drink and don't dehydrate. Once the deployment is complete, we get a handy go to your resource notification, and we can go to create a LUIS application. So it will redirect us to the quick start as the first, and we see the first point is the create a LUIS application. So we will hit that, and this, or maybe this was the wrong one, sorry. Maybe Sandro, can you please go back to the portal?
Of course.
We need to find the right link, so probably under overview then. And here, or we'll just do it easily because I know directly how to get there. So just open a new tab. This will be very easy. There should be a link somewhere in Azure as well, probably, but you can also type in LUIS.
Okay, LUIS.
.ai, very simple. And so we have the resources and everything are in Azure, and then on top of that, there is the LUIS portal, which we are calling right now, and you can log in with your Microsoft account. Use the one that you've created the resource with, please. Select the subscription we use to create the LUIS resource. And, or maybe cancel this one because it wants us to create a new one. Does it? Oh no, sorry, you need to select choose a different authoring resource, so it was right, so sorry about that. And we have the subscription, and we select the one we just created. This is the one, and we hit done. And it will take a second to load everything. And I think it's all good, so we can select the plus sign with the new app to create a new LUIS application. We give it a name as well, so shopping list maybe. We can select the cultures, or depending on your language, for our workshop we will use English, but of course, because this has to deal with language, it can be optimized.
There's a bug again.
Maybe if you reselect the... Oof.
So sometimes there seems to be a bug. We haven't figured it out why it's happening. And
maybe a refresh will do.
So perhaps we need to create it from scratch.
Okay. Do you maybe want to load the entire website again? So that might be helpful, maybe.
So as you can see, even Microsoft is not bug-free. Shopping list. Now the culture is loading a bit.
Wish us luck. Hopefully the website works. The portal.
Okay, and again, we cannot choose English.
Then otherwise,
can we just use done? Interestingly. So usually I think English is your standard choice, so perhaps it might work.
Oh, that would be nice.
In the meantime, I can...
Oh, what I would say, if you have time, and because languages are important and inclusiveness is important, hit the little smiley. So not for you, Sandri, but anyone else in the top bar, and give them some feedback that this is kind of broken.
We have a server error in
Okay, maybe
I will try
refreshing.
one more.
So no, refresh first one more time, because if you use the same, it's probably like already loaded everything on your browser.
So this looks like there's something loading. And now we can not choose anything.
Okay. So sorry about that. I mean, you can see that that's not up to us. That's not in our hand. However, I think there's a way around. I will just export the already existing one, and I'll send it in this chat. So this is actually quite nice with the bot framework. If I take, you can simply extend with the LUIS, you can simply export the entire thing as JSON, and I can paste it. I can send it to Sandro, and I will send it to all of you. So let's find that Teams chat. And we will also provide those materials in the repository, so don't worry. But for now, that's to advance. So Sandro, did you receive the file?
Yes, I
in Teams
downloaded
so
it.
You should be able to hopefully import, and hopefully this part of the LUIS portal is working right now.
Now I see the chaotic lecture recording room file structure.
We can't actually see it, so you're all good.
You can't see it? Great. And which time do we use? That name do we use?
Shopping list.
Shopping list.
Like the file is called, or whatever.
Okay.
Probably doesn't matter. Hopefully it doesn't need to be the same as how it was called before, and hopefully this is working, this part of the portal. Then we would be lucky.
So we will figure it out.
Let's hope for the best, plan for the worst.
Import app failed. So I think there might be some problem right now.
Okay, so do you want me to share my screen with the already existing one, or should we just sadly
just share your screen and we can continue later?
Okay, so I will. That there are even pre-built ones. So if you have something that might relate to any of the points here, you can get started very easily. For example, we've used, there's the add one, and you. However, they might not fit perfectly, so you can still modify them. So that's the add item that we've got. And now maybe if you can write in the chat some input that you have, maybe how would you tell a shopping list to add some items?
Of course, you can tell us the input as well.
Yeah.
If you don't want to write or cannot write.
Don't be shy. It requires a little bit of creativity, but I think every one of us can come up with a sentence to add to a shopping list.
So I would like to buy 500 grams of flour.
Okay, I would like to buy 500 gram flour. By adding this to the add item intent, we already specified which intent this sentence belongs to. We can hit return and it will enter the sentence. Except if so great. I almost thought that the entire Louis thing is down, but it seems to still be fine. So now we can see our sentence here. And as you can see, Louis, based on all the sentences we've trained it beforehand with, shows us a suggestion what it could figure out about the sentence. So it could figure out that this one here is a number. It's quite small, so maybe let me zoom in. That might be too close. Here, that should be fine. So you can see it thinks this is the number, and that's fine. Here, on the other hand, it thinks this entire thing should be the item name entity. I think that's not perfect, so we will click the flower and mark it as the item name. So by doing so, this is basically how we train Louis to recognize other sentences that we might give it to its machine learning algorithm. And the unit, it's also fine. It could recognize the gram. So now we are happy and we can confirm that we want to add the sentence. So this is basically all you need to do to create a language understanding service. You basically need to be a little bit creative to come up with a ton of sentences that relate to your use case, and then define the entities. So we have them here, and there are different ones depending. Maybe the number is quite easy because numbers are numerical, but the item name is not so easy because there it needs to be smart about the machine learning algorithm needs to be smart about separating the flower from the I would, or the which part of the sentence is the item name. And then you can also test your Louis right here. So if we add 2 oranges, we can send this off and it will tell us that it's 99% sure that it's the add item intent, which it obviously is, and it shows us all the information it could extract. So it could extract that the item name is the oranges and that there's a number 2 involved, and then our bot can use this information.
And don't forget to drain or write those sentences.
So the sentence we've added here, you can see, is still dark and not gray because it hasn't had any effect. Actually, this one seems to be still labeled not perfectly. But if we retrain, then the new sentences that we might add will be taken into account. We don't need to worry about that for now. And then
also, as you can see, if you would write, I would like to buy 500 gram flour now, then Louis doesn't recognize this I would like to buy, but only the 500 gram and flour. So in your shopping list at the end will only be 500 gram flour.
And then when we are happy with the model we've trained, we can publish it and we can always go back to refining it. But based on this, we can get the information. So the endpoint URL is important, the location is important. And let me check with the Visual Studio Code. So this is now where we configure sort of the bot to use this specific Louis model. And Sandro, I think now it's your turn to share your screen again.
Yeah, no problem. Give me a second.
Because I don't have access to this file that we need now. we can live with it. And if you ever have trouble connecting everything, you can simply ask. And if you go to the .env file.
Yes, of course.
In the bot.
Do that.
This is basically where we tell the bot which ID we want to use for the LUIS and where it can find that. And with that, we are perfectly good and have everything wired. And I think we can go back to the presentation.
Okay, so we finished part 1, and the second part is obviously the rest of the presentation. We call it just part 2, and Malte will provide a short theoretical background, and then I will take over for an interactive implementation.
All right, now that we have the bot, we still need to take care of persisting the shopping list, because in the bot, we've only queried the communicate with the user. For that, we are using Azure Functions. If you don't know what Azure Function is, here's a little comparison. So we have we have the bot functionality to query the user for items. But if you have a shopping list, you obviously also want to do something with your vegetables and all your shopping items. Maybe you want to cook them. In a similar case, we still need to use the information that we got from the bot, and we will do so and process them in the functions. On the left-hand side, the pizza oven stands for a typical server, and the right-hand side, the more modern oven, is the Azure Function. While the typical server will run all the time, the Azure Function is off for now. But if we go to the next slide and we turn on and we maybe want to make some food now, we see that the serverless architecture takes care for us to turn it on, turn the oven on. And now we are only using the oven when we are actually making food. Quite handy, don't you think? Or I don't know about you, but I don't have an oven 24 hours running. On the other hand, there's still a use case for servers. So if you have a restaurant maybe, and we have a bunch of pizzas, then we can maybe, it makes financial sense to have the server running all the time. Because the server is running all the time, it doesn't need to warm up. The Azure Function, on the other hand, you need to preheat your oven often. You need to wait for it to be hot. Well, at least if the modern oven is running, then it's totally fine, and then you can send as many requests as you want. And even beyond that, the oven scales really well. So the Azure Functions, the infrastructure takes care of providing more resources if you have many requests coming in. So if we go to the next slide, we will focus more on the Azure Function. This was just to give you an overview on the relationship to traditional servers. So now let's bake something in our more modern oven, and we do so by using recipes, or in our function world, this will be done by not the pizza, and the recipes are for chicken, so it doesn't fit quite well. But anyway, we have to provide different recipes that in the functions will be, of course, our code. And then depending on what kind of thing we want to eat, we can send requests, and then the function will invoke the right code for us. So that's a quick overview of Azure Functions. And now, second technology we are about to use are Cosmos DB. So as you can see, we are keeping it simple for this one. We have a comparison again. On the left-hand side, there's this bento box. It is food neatly arranged into different dividers or categories. So that might be your traditional SQL database where you have a clear structure of how you organize the data. And on the right-hand side, we have our lunchbox. So this is not as neatly and more functional, one could say, in the sense that we can simply take our food, or in the non-relational database case, our data, and dump it in there. Yeah, more chaotic and yet delicious. Yeah, that's awesome. And it can also be quicker and provide other benefits. So these are both, again, I hope those icons show you that they both have a place. So they are both relevant. In our case now, we are using the Cosmos DB simply because then we don't need to worry about defining a schema for SQL, and we have a NoSQL database with Cosmos DB that scales really well and that we can use for our use case. And with that, I will hand over to Sandro again to show you the more practical part of these two technologies.
Okay, let's take a look in our Visual Studio Code again, and I will need to arrange my keyboard and turn away the iPad. So what we have here is, I hope you can still see it. I just closed the bot. We have this functions folder, and we have already predefined Azure Functions and also a helper class, which we will extend. And we have also this local settings.json, which we will take a look in a couple of seconds. So the first thing you will need to do to create a new function is, if you don't have any function yet, just go into your Azure Functions extension and create a new project. However, we have already a project here created, and if you pulled the repository, then you do have it as well. I just need to drink something. So in this case, we will use the second option, just create a new function. And then your extension will ask you which trigger you want to have. For our use case, we use the HTTP trigger because we are sending HTTP requests to the functions, and then our add item function, which we will build, will be triggered. So we call it add item function. And for the authorization level, we just use anonymous. And then we can see the extension is creating some code for us, which is basically everything we need to build a simple Azure function. So we have here a async function using context and request as parameters, and it will return a promise of type void. We could change this depending on what we will implement. And yes, so in our request object, we have a body and we have queries, and we can basically write down what we want, ask body and query. And where can we specify that? We need to open our function.json file. And here it's basically the definition of our function. So we are creating a add item function. So having a get HTTP verb does not make sense. We will just remove it. And we will use the post. Yeah, if you need for your function another method, you can also use patch or delete. So any HTTP verb you want to use. And then we will also add our endpoint. So under which endpoint our function is available. And this is called route. And our route, we will just call it add item function. And then we need to specify the conversation ID, which represents our chat conversation. And that's basically everything we need to specify in the route, because our item is sent via the body. Okay, let's take a look into our function itself. So we will open again the add dialog function. And then we will think of what we need to do. That's not the right function. So that's the one. So first of all, usually we need to find out whether all input is correct. So we want to check whether our conversation ID and the item which is sent in the body are valid. I will just edit this that way so it works. And how can we access the conversation ID? We will just declare a new constant which we call conversation ID. And perhaps a question for you guys. So we have this context and we have the request object, and we can always use context.request or context.response. And there's also for the conversation ID something which is called binding data. So anything which we have here declared in our function as bindings. And here we have the conversation ID. So what do you think? How can we access this conversation ID in our binding? Do you have any ideas? So we will use the context and then the binding data, and then it's simple because we just use the conversation ID, and that's how we can access query parameters. And now we will take a look whether our conversation ID is valid. So it's obviously not valid if it's undefined, and it's also not valid if it's an empty string. I will leave that out right now. And we can take a look how we access the request body. So in our shopping list bot, I will open the file for that. We have this function service, and we have here written by Malte this add item operation, which gets a conversation ID and an item to add, and then we will send a post request to this endpoint having the item itself as a body. So this is more obvious. How can we access the body here? Any ideas from you? So we have already, there's something in the chat. Hello, I'm sorry, I missed a... Yeah, the event is recorded and also streamed on YouTube, so you can also watch the recording in YouTube or in Microsoft Stream later. So where were we? We have this request object reference, and we can use there the body property, which gives us the body. And we have our item stored in the body, and the item must not be undefined. And additionally, an item does not make sense without an item name. So we had the unit as optional, however, the item name was necessary. So we will just take a look if our item name is undefined, and if any of those cases are true, then we are entering this if clause. And what can we do? We just write a 400 bad request back to the user or whoever is accessing this Azure function. And you can take a look here how we can do this. So we will just write context.response, and then we will send a JSON object with the response, and we specify the status as 400 for bad request, and also perhaps a message in the body. I mean, you can change it the way you like. So message, and what do we call it? For example, invalid input. Okay, now there's still a problem, because if we use this context.response, then the function is not finished. So we need to finish the function ourselves, and as it is an async function, we need to return it. So in synchronous functions, there's also the concept of context.done, which, as you can see, should finish. Should finish the context and will also send our 400. However, the rest of the function will still be called, and we do not want this. So we need this return statement here. And that's basically the defensive programming of our public function. And now we are trying to store our item itself. So we could just take a look which item we have. So we have an item in our request.body, which is not undefined and has a valid item name. We could also check whether the item name is an empty string or not. Perhaps I need to import this. That's the correct one. Okay, and we want to store this item in our Cosmos DB. And for having a unique or clear interface, we build this. Where do we have it? This Cosmos DB service here, which is basically a helper for all our Cosmos DB operations. And if you want to do the workshop on your own, it's quite well documented, so everything should be clear. And so this Cosmos DB service uses the Mongo client as API. So what we didn't tell you is, perhaps I can show it in the Azure portal, is that you can access a Cosmos DB via various API versions. Oh, that was the Cosmos DB already. Azure Cosmos DB. Okay, it's taking quite long to load. So you can either access the Cosmos DB using an SQL API, or you can also access the Cosmos DB using, for example, MongoDB and others. Hopefully it's written down here anywhere. Usage information, no. Okay, you can find it out in the documentation as well. And first we tried in our creating the workshop this SQL API, because you can use it as binding for the functions. However, we run into some problems there, because updates are not supported, which we will explain later in more detail. Yeah, now we have created a Mongo client. So you need to import this MongoDB. You can just write down npm install MongoDB, and that's it in your console.
Sandro, you're still on the browser for me, so I don't know.
Thank you very much.
You need to switch the window.
Yeah, that's the problem when you're using OBS instead of sharing your whole screen. Yeah, so we use this MongoDB, and I can write it down again. npm install MongoDB, let you use the library, and we can create a new client there. So the class is the Mongo client, and in our Cosmos DB service, we create a constructor which just will initialize this Mongo client and set our conversation ID. So we provided this for you. That's nothing really interesting. The only interesting part here is that for the Mongo client, you need to use the credentials for your Cosmos DB, and since the client API with the constructor with only one argument is deprecated soon, we also need the second argument. And you can write down in the functions your your environment variables in this local settings.json. So you need to create it on your own, local.settings.json, and then you can create here under values environment variables of your choice, and we just chose the shopping list Cosmos DB. So where can you find the credentials? We will go back to our Azure portal, to our dashboard, because we already created a Cosmos DB using Mongo as API. And if you created one yourself, then it's basically looking like that. So we have here an overview telling us our URI and resource group, etc. And you can go under connection string. And here you have your host, port, username, primary password, secondary password, primary connection string. And this one is the one we want to use. So we can just copy it. And then we go back to our Visual Studio Code and paste it here. And don't worry, you can copy everything you want. We will delete the resource group after the meeting, so there's nothing you can destroy. Okay, let's go back to our Cosmos DB. So we created this Mongo client, and now we want to write this add item function, and that's something we can do together. So let's read the documentation first. Obviously, this operation will add an item to the shopping list, and in our item, you can take a look at it in the models. We have a position in shopping list property, so we will need to set this in which position our new item is in the shopping list, and we will use this in the get items operation in our shopping list bot, which you can take a look for yourself, and if you have any questions, do not hesitate to ask us. However, we will not implement this in our workshop today. Okay, and for finding out the number and then this new position in the shopping list, we need to find out how many items we have already stored in the shopping list. So we need to retrieve this number first, increase it by 1, and set it as a new item. And this operation has also some preconditions. So obviously, again, the item or item name must not be undefined, and the item's name also must not be an empty string. I will skip the check here because of time reasons, and we will create code to provide this post condition. So when we take a look in this Cosmos DB service, we need to, where is it? Here is it. Connect our client first. And that's also something we provide to you. So with our MongoDB client, Operation Connect, we can connect the client. We will need to wait for that because it's an async. And then we can just select a database and a collection, and you can choose the names in your Cosmos DB yourself. So we decided for shopping list DB and items container. And the collection is basically the bucket for our items. So we want to store our items in a collection, and we can modify or remove them from the collection and in the collection. So we will return this collection, and that's providing us every operation on the items we want to use. So const collection, I'm not able to write correct English. This point get, no, connect and get collection. Okay, and connection, as you can see, or cannot see, what can we just, there's an S. Collection dot. This is working quite well. Connection dot. Are you kidding me? Collection, nicht connection. Yeah, we can use many operations here. For example, delete one, find one, etc. pp. So our first task would be to find out how many items we have in the shopping list. And do we have any idea how we can do this? I should open Teams again. Okay, we have here a find operation. And when we take a look at the documentation there, it would say that you can find items and right. We need to await this connect and get collection because it's also async. And then we can use the find directly. So what we're expecting here as an argument is a filter which items we want to find. And that's more easy to find out. So we have two main properties we can search for. The first one is the conversation ID, and the second one is anything which is stored in our item. And since we want to add the item, it does not make sense to search for the item itself in our collection. So obviously we need to take a look at the conversation ID, and we want to find all items which are already in this collection for the conversation ID. So we have here a JSON object which uses the property of our item, which we called conversation ID, and then also the value. So perhaps we take a look into our Cosmos DB again. Great. So in our data explorer, we can take a look at the data, how it looks like. And you can see we have here multiple collections. The first one is our shopping list database with our items container. So this is basically the collection itself, and as documents, because it's a NoSQL database, we already stored multiple items, and we will just click on one. So any MongoDB item will have this object ID, which is basically set from MongoDB itself. However, you can also override it when creating an item. And we also wrote down the conversation ID. So you can see here we have a live chat conversation ID, which is done by the emulator, and we can show that in a few minutes. And our item itself. And this item seems to be at position 5. So there need to be 4 items above for this specific conversation ID. Okay. Great. So we will find out all items with our conversation ID that we provided in the constructor. And then this API offers us another operation, which is called count.
You're still on the browser window again. Again.
Thank you. So use this count operation, and this is either expecting a callback or we will await for the find. And then we have the count of our items. And since we want to increase it by 1, we just add +1. And we store it in our new position in shopping list, for example. So now I need to take a look. Perhaps we don't need this collection find. Yes, that makes more sense. Yeah, so we will filter for our conversation ID, count the elements, increase the output by 1, and store it in our position in shopping list. And then we can return our new inserted item. But before we do that, we need to insert it. And obviously, there's also a API operation for that. So await collection dot insert 1 would make the most sense. And then we need to provide the document we want to add, and also either a callback, or since we are waiting for the result, we don't need to provide the callback. And yes, which item do we want to add? We want to create our new item soon. I will just remove the callback. So is anything clear? Is everything clear right now? Or do we have any questions? Then just take a look again into Cosmos DB. So what we have here is how a document looks like, and we have this ID, which is generated by Mongo itself. We have a conversation ID in the root level, and we have our item itself in the root level. What we got as argument for our operation is only the item, and we have the conversation ID as attribute for our class. So we will need to create a new object, which basically looks like the one we are having here in the document, having the conversation ID and the item itself. And now I don't forget to go back to Visual Studio Code. So it seems there are no questions. yeah, it can only be so interactive as you want to be. So if you want to try it out yourself, then please do not hesitate to write something in the chat. Okay, we want to insert a new item, and we know there needs to be a conversation ID property, and this is obviously the conversation ID we have provided in our constructor. And the second one is the item itself. And here things get a bit messy because we cannot use directly the item we were providing here. I mean, we could also use it and change it before, because we need to add the position in our shopping list, which we retrieved here, to our item. So what you can do is using the constructor for an item, and then just use item dot item name, item dot marked our position in shopping list and the unit. So that's it. And now we need to try it out or just read the documentation. This insert one gives us a, perhaps it's written down here, a insert one write operation result of type any, and we want to retrieve the item itself, which we have added. Why do we want to retrieve it? I mean, either we just add it and don't return it, but perhaps it would be nice to get the item which we added to the shopping list back to further process it in our bot. Okay, we have here the insert one, and then we need to take brackets around that, because now we really need to wait for the response and use this operations stuff or whatever this stands for. It's not very clean code. And since we have only one element in our array, because we inserted one, we need to get this first element, and we just want this item property, which stands for our item. And now we can return this. So that's basically how you can store new elements in a Cosmos DB using the MongoDB API. And you can also take a look on the other operations, what we did there to remove or get all items. Okay, we have written down this add item now, and there might be some errors, so we can also add some error handling. Try this. And what we never should forget is to close our client again. So we have a finally, which uses this client dot close, and we can also await this. This Mac keyboard makes me tired. I'm often using the wrong key. Okay, we close the connection, and if everything works, then there's no error. However, if something went wrong, for example, the conversation ID was broken or whatever, then there might be an error, and it's propagated back to our Azure function. So we want to add here also some error handling. And what can we do? We can also put this in the try catch, for instance. And we have this item, and we want to call our Cosmos DB service. So we need to declare it first. Cosmos DB service, for example. Cosmos Cosmos DB service, and we need to provide the conversation ID we are having here. And now we have a new Cosmos DB service, which we can use. And yeah, we want to get our item added or added item back. And we will use this Cosmos DB service add item operation, which gets the item as argument. And yeah, now we have our added item if everything worked. So we can return it. And how can we return it? We just use this context again with the response property, and we will provide a JSON object here, and the status is usually 201 created. And we want also to add our body with the item we were adding. Okay, and here we can use some error handling. For example, we just return context.response. I don't know, status seems to be 400 here because something went wrong. You can choose something which suits better. And as a body, you want to give, or might want to give, a suitable error message. Okay, that's so far from the Azure Functions, and I think I didn't miss something. If I did so, and everything will break down soon. So we want to start it. And you don't need to create a Azure Function service on our Microsoft Azure. You can just write npm install first to install all modules, if we didn't do that. And then using npm start, we can start our functions. And unfortunately, I missed to install Postman here, so we could try it out. However, we can just try out another function, for example, this getItems function. So I will just copy this one, and now we can go back to our web browser. We need to copy a conversation ID. For example, we have it here. And then you can see the functions are working locally as well. So we have here a serverless application, more or less, which we can host locally. And you can also upload them on Microsoft Azure if you want, just using the Azure extension or building a CI with GitHub Actions, for example.
Sandro, if you have a second for a question, there is one in the chat.
Oh, okay, there's one in the chat. Sure, we have a second for a question. Wow, it's already 8:13. So I just want to ask, I never used JavaScript before, from where you recommend to learn how to use it. I never coded before something harder than a turtle in Python. So actually, I'm not sure whether there are good JavaScript guides, or how is it called? Something where you can learn it. However, I would highly recommend you to directly start with TypeScript and not getting your hands dirty with JavaScript first, because writing in dynamically typed languages can be a bit tricky. Yeah, so I don't know. I would suggest you to try it out, just try to build stuff you were already building in Python, but using TypeScript now. And the most important thing as a computer scientist or software engineer, whatever you're calling yourself, is to be able to read documentation. So I don't know how many hours Malte and I spent for reading documentation, and a lot of the documentation was really bad, especially for the bot. And I think that's a normal process for everyone.
If I might give a suggestion, feel free to take a weekend where you have some time and go look at our repository, rebuild the bot, ask questions. We will provide the links for everything later on. So maybe if you have wanting for a weekend project, that might be a good start with TypeScript programming.
Yes, perhaps it also makes sense to wait for 1 week because we will provide some further documentation there, so it's more easy to write a bot yourself. Okay, you're welcome. Malte, what did I miss to explain? Perhaps we can try it out whether...
To me, it sounds all good. I think we can maybe show the final bot. Everything
okay,
working at once.
I will just take a look. Oh no, my screen tells me it will shut down in 200 seconds, so I will deny that. Yeah, we need to go to our shopping list bot directory.
You need to also switch to Windows then again.
Thanks a lot. I'm always forgetting this. So with CD, I just added a new terminal, and with CD shopping list bot, I switched to our shopping list directory. And now we're in it. So I just use npm install to be sure that everything is installed on this event setup here. Since it's taking that long, I expect we haven't used the npm install before. So can you see the terminal in a suitable or appropriate size? I hope so. Otherwise, just tell me. Okay. Added 554 packages. And with npm start, we will start our bot. And now, fingers crossed. Yes, it works. So let me explain you how you can test this bot for yourself. You can use this bot framework emulator we have here. You can download it there, and I mean, it's written down. And you have a URL with port for using this bot, and we have already prepared it. So you can use this open bot here, write down localhost. So you need to use the localhost, not this bracket stuff, with our port. And you also need to add this /API / messages. But the bot will tell you here whether you make some mistake. And then you use connect, and this will lead you to your chat. I will just restart the conversation to be sure that it works. And I don't know, let's add 200 gram bananas if the bot asks us so gently. And it's added 200 bananas to our shopping list. Perhaps we can take a look in something more special, which we can find in Cosmos DB later. So have you any ideas what we can add? For Dominic, we add 4 cars to our shopping list. Dominic is the colleague of us who is streaming on YouTube. So which item? Okay, we haven't trained for cars. Added 4 cars to your shopping list. And now you can also see what's happening if Lewis cannot identify these cars as an entity. We will just be asked from the shopping list bot. And we can also request all. And then you can see, hey, we have here 200 bananas and 4 cars, whatever we want to do with them. So we bought them, we will check, and we will save. And there seems to be an error. Turn error. So there might be a bug with this update. So just take a look in our portal again. We will not fix this bug yet, or in this workshop. And most likely the last one are our cars, hopefully. Okay, it's taking a bit to load. Yeah, never mind. So we could try everything here out, but I think that doesn't make sense. Somewhere in our code, there will be our cars and our bananas. Okay, and I think we can also show it with a Telegram bot. So what we prepared here is a Telegram group chat for you, or for us. And you can see it's not only working with this emulator, but also with a group chat in Telegram as well, or single chat. And I don't know, Malte, just give us something. What do you want?
What do I need to cook? Maybe I need some tomatoes for my pizza. So I need tomatoes, or add, maybe we should specify how many. I need 500 grams tomatoes.
So what I thought is that you're writing, but it's fine as well.
Oh, I didn't get that hint.
And I don't know, is our bot down? Timeout after 15 seconds. That doesn't look good.
Well, that's the nature of the functions. So you know previously how we discussed the oven example, the pizza oven is running the entire time and the functions need to heat up first. So obviously they weren't ready yet, so maybe.
So the more important question now is whether he really added the 500 gram tomatoes or not. And now it's much more faster.
Because now you see the functions are ready, they've loaded and they're working. So we could definitely optimize our bot in this regard. But now that it's running, it's totally fine and we can list everything.
And you can see in Telegram the adaptive cards are not supported, so you need to take a look whether your messaging application supports them or not, or how you can do it then with the marking. Okay, I think we can continue with the slides for the final part. So let's take a brief look at limitations, lessons learned, and how you can train yourself for giving the workshop for yourself. So the limitations, currently we do not have any text similarity. So there would be an idea to compute any text similarity in case we have some error mistakes in writing cars or bananas, or if we have longer items, and that's something text retrieval you can just use algorithms which are already existing. So nothing spectacular here. And the good thing is you can write your functions in your own language of choice. So currently, I think Python is supported, Java, C#. Obviously, TypeScript and JavaScript are supported. Perhaps you want to use a different language on that. We also have no authentication right now in our bot. So we used this client connection, no, how is it called? Conversation ID as semi-authentication, but obviously that's not really secure. And it's not really clear from the documentation whether this conversation ID is not changing or whether it might change in the future. So perhaps there's a bug. And last but not least, our bot is not yet channel specific. What did we mean with that, Malte?
Well, so for example, the basic bot just processes the messages. However, different channels have different functionalities. For example, Teams provides different functionalities for bots depending on the context they are in, which might be useful and might be explored or might be worth exploring in the future.
Yeah, you might have recognized that a bot listens to everything, so it might also be helpful in a group chat in a normal to just use the bot if you're explicitly tagging him. Okay, I think Malte will continue with lessons learned.
Yeah, regarding the first aspect, this is one I've already mentioned very early in the beginning. The mindset is a different one. Instead of writing UI, you basically think in messages and dialogue and want to compose them. We've also learned that the emulator, for us, sadly, even though it's supposed to, doesn't support any group chat. We could start it. So debugging this functionality with the group's IDs, as Sandro mentioned, wasn't as easy, and we had to deploy it first and add the Telegram channel to actually get the group chat, to actually try the group chat. Then in the beginning, we've started out using the SQL API with Cosmos DB. However, we've quickly learned that Cosmos DB is a no SQL database for a reason, and trying to squeeze SQL in a no SQL database only works for really simple scenarios. So once we got to trying to update items in our shopping list, we decided to switch over to the Mongo API. Lucky for us, Cosmos DB is flexible enough to allow for that.
So first we tried this bindings in the Azure Functions to add items, which worked quite fine, except that you need to write SQL statements for yourself, and you do not want to do that. However, when you are facing some bigger issues, then you're trying out this Cosmos DB client, and you will find out that the SQL API does not support it, and the bindings don't do as well. Please continue.
And for the last point, it might be worth to mention that reading documentation, as Sandro mentioned before, was one of the main aspects of implementing this bot. And sometimes reading documentation can be really difficult, especially when you come to the part where you want to connect things together. So, for example, the adaptive cards documentation in of itself is really nice. The adaptivecards.io website is awesome to learn more about adaptive cards. Nevertheless, then working with adaptive cards inside a bot becomes quickly difficult because the documentation might not be sufficient. Like, for example, how do you find out in a bot which channel supports the adaptive card? You then don't have the simple ability that the framework takes care of that for you. So documentation could be improved at some areas. And maybe through this workshop, we can contribute to that once we've written up our final documentation on GitHub. Either way, we hope that you might take a look at the resources we provide you and maybe are interested in taking or holding this workshop yourself. So for that, we have another slide.
So it's called Train the Trainer, and as you might know if you listen to other weekly workshop series, we're supposed to provide you with information how you can prepare for giving the workshop yourself. Perhaps before we start with this conversation, I can give you the hint that usually such workshops work much better in person if the people can write themselves and you can take a look over their shoulders. So on the left part, we have a usual app developer, and on the right part, we will have in our chat the bot developer for workshop, or I think it's a general workshop developer as well. So when the usual app developer is taking care of functional completeness, a workshop developer might concentrate on simplicity first. So as you might recall, we haven't taken a look into authentication, and also some error handling was just basic for simplicity. And then there's also the testing and security stuff. So while you always should test your code for production and perhaps also have some security measurements there, for workshop, you only need to have basic concepts because, to be honest, no one will use the workshop bot in production. And you don't need to take care of that. It's just taking time and is hard to implement. So the third point would be that usually in the normal app development, you document the code for others to use, so they should use your code, and then you need to document the code in a way that they know how to use it. However, when creating a workshop for students or whatever stakeholders, it's kind of a bit different. You need to document your code or artifacts for others to replicate it. So that's something still missing in our workshop. However, we will create it, I think, in the next 2 weeks. So you can do the workshop unsupervised for yourself. Malte, I think that's your time.
Oh, sorry, I was muted there. If I put on my regular developer hat, I might not be bothered with marketing because maybe my company has a department for that and they take care of it. However, doing events like this, don't forget marketing. Make sure that you spend enough time talking to people, creating posts on social media, creating maybe some artwork that you can distribute. Then in the next aspect, when I develop for a company, I need to somehow earn money, so it should be a profitable project. However, in this community aspect, be also sure to have fun and learn along the way, and don't be too worried about deadlines and everything that is bugging you down in regular life. And last but not least, definitely don't be afraid to ask questions. We are all not perfect, and getting help is the best thing you can do if you are stuck somewhere, if you don't know how to continue, if you don't know how to get started. So reach out to people who might know, who can help you, who can provide you resources. And with that, I think we can close out with our last slide.
Yeah, actually, it's an anti-pattern to close with that. Yeah, thanks for listening to our talk, and hopefully you could take something with you. I will just go back to another slide because never end with thank you slides. Okay, do you have any questions?
I think the train the trainer one would be nice.
I think your animation is kidding me here. I'm running in the endless loop. Okay, we will go back to the train the trainer. Yes, and you never know what will the outcome for your workshop. For example, we were asked by the cloud advocates whether we can provide them a bot for adding tasks into some storage. So they have a group chat and they are bothered by writing tasks down and then they get forgotten. And when our mentor, is mentor the female form, I don't know, so Aisha found out about this workshop, she was thinking, great, we need this. Okay, so I think there's no question and we can end the session. Again, thank you for being here.
Thank you.
Have a nice evening or afternoon, wherever you are, night.